Hello, welcome to my channel. Today I'm going to discuss about the water biochemistry. So water is most abundant substances into the living system. About 70% of body's dry weight are taken up by the water. 70% of dry weight are taken up by water. Water provide the aqueous environment where different types of the enzymatic reactions being happen in this aqueous environment. The molecules are being transported into the cytoplasm, where it will break down to forms the ATP. So water plays a significant role in our body. Without water, it's not possible that the body are going to survive, and the enzymatic reactions are being happen. Another features of this water molecules is water are being easily ionized to forms H plus to an OH minus ion, and this is the equal amount of H plus and OH minus ions are being formed, and this H plus ion being accepted by H2 molecule to forms the hydronium ion, H3O ion, H3O plus ion. And through this process, this proton are being transferred very rapidly from one place to the another place and very long distance. That helps to make different proton gradients or chemical gradients, through which ATP are being made. Okay, so this water molecules plays a significant role. The water are polar substances, are polar molecules. As this is the polar molecules, when there are some polar substances are added into the polar molecules like water, it will be dissolved. Okay, maybe it will be dissolved by forming the electrostatic interactions, forming the hydrogen bonds with these solid molecules, and thereafter it going to be dissolved it. Now if it is in aqueous solution, if the molecules is the nonpolar, what happen? It going to be forms the cluster. Suppose it's the ionic component, suppose NaCl, Na plus and Cl minus. What happen? The water molecule forms the electrostatic interaction, and electrostatic interaction, what happen? This electrostatic interaction are going to separate this molecule from each other. Means electrostatic interaction are greater than this ionic interaction, so that these two molecules are separate with each other and going to be dissolved. If it is, and suppose in glucose molecule that have a OH group, functional group, the water molecules are being from the hydrogen bonds with that, and going to dissolve it. Okay, same process. But if it is in a non-polar molecule such as lipid, so what happen? If it is a non-polar molecule such as lipid, so what happen? Water molecules are not able to form any kinds of bond, as because the negatively charge is evenly distributed around the molecules of the nonpolar molecule, because these nonpolar molecules have a carbon skeleton that have an carbons and the carbon and hydrogen, which have an equal electronegative, carbons and hydrogen equal electronegative, and electronegativity of this carbon is about 2.5, and the electronegativity of the hydrogen is 2.1. Okay, this something like that of equal electronegative, and the difference between this electronegative charge is about 0.4, which is very low, that make it very non-polar molecules, very low polar molecules. Okay, so what happened in this time? Water molecule is not able to form the hydrogen bond. It going to be arranged surrounding the hydrocarbon, and it will be arranged surrounding the hydrocarbon. What happen? So the hydrogen bonds are being stabilized, but sometimes when the another hydrocarbon chains should come here, and it will be forms the micelle like structure, so that the hydrophobic regions are going to be inside and the hydrophilic regions are going to be present into the outside, that forms the hydrogen bonds with the water molecule. Alright, so water is the universal polar molecule. Now let's just consider about the geometry of this water molecule. Water, the central positions of this water have a oxygen atom, and the two pole have a two hydrogen atom. Now each poles share equals amounts of electron. Each poles of the the hydrogen atom presents into the each pole that share equal amount of electron with the oxygen atom. Here oxygens also share the equal amount of electron to forms the covalent bond. This is the covalent bond which is formed in between this oxygen and the hydrogen. the sp3 between the sp3 orbitals of this oxygen and the 1s1 orbitals of the hydrogen. This is the covalent bond which is forming here. Still now the oxygens have two unpair non-bonding electron pairs which is in here, non-bonding electron pair which is in here. Sorry, this is non-bonding electron pair which is present in here. Now if you consider the electron orbit, outer electron orbitals of this oxygen which have a structural geometry with the sp3 orbital of carbon atom. Which have a perfect tetrahedral structure. This is the tetrahedral structure, perfect tetrahedral structure, and the bonding angle between this is about two atom is about 109.5 degree. Okay, now consider side by side with the oxygen electron orbitals and this carbon electron orbital. The carbon have a valency is about 6 and the electron distribution is 1s2, 2s2 and 2p2. Right, now into the ground state when you put some energy into the 2s orbital, what happen? The electrons are going to be moved from 2s orbital to 2pz orbital. The 2p are going to be divided into the 3 orbital. This is 1s2, this is 2s, this is 2px, this is 2py and this is 2pz. Now 2s2 have a 2 electron itself. Now 2s2 in the first stage it have a 2 electron, but when we are going to provide some energy, this energy are going to shift the electron from this 2s orbital to the 2pz orbital. Now the fifth electrons are going to be coming here and the sixth electron are coming to the 2py orbital. Now let's consider here the 2s orbital and all the p orbital have a one single electron which is finding for their opposite spin partner. Now this 2s orbital are going to be hybridized with the 2p orbital to form the sp3 orbital. So now it's going to be hybridized to form the sp3 orbital. So how many sp3 orbital are being made? 4 sp3 orbital are being made that have a 1 electron each. This is the hybridized sp3 orbital. Now this hybridized sp3 orbital, this geometry of this hybridized sp3 orbital are contributed 25% of 2s orbital and 75% of the 2p orbital. Now what is the structures of this in here? Now here in the central position, this is the nucleus, and outside the nucleus it have an 1s2 electron cloud in here. Now we have an 4 sp3 orbital with 1 electron each. This is 1, this is sp3, this is second, this is third, now this is fourth. Now each orbital have a one single electron and these electrons are spinning around along the axis of the sp3 orbital. Now in this state the sp3 orbitals of this carbon are going to be submerged, or it going to be overlapped with 1s1 orbitals of this carbon atom. So this is the 1s1 carbon atom are going to be overlapped, 1s carbon atom are going to be overlapped, 1s carbon atom going to be overlapped in here. Now this overlapping happen along the same axis, So this overlapping happening along the same axis, due to this overlap between these two orbital 1s1s and this sp3 orbital happening along the same axis, so that it able to produce the pi bond, and this is the strongest covalent bond in between the carbon and the hydrogen atom, pi bond. And this is the perfect tetrahedral structure too. Look at the tetrahedral geometry of the structure. This is the tetrahedral geometry, and the bonding angle in between this is about 109.5 degree. But this is not possible in the case of this oxygen, in the case of this water molecule, as because the water, the oxygen molecule present in the water molecule, it is also have a sp3 hybrid orbital. So let's consider about the oxygen. The valencies of this oxygen is about 8. Now going to electron distribute. Electron distribution is 1s2, 2s2 and 2p4. Now here the 2s2 and 2p4 are going to be hybridized to form the sp3 hybrid orbital, where it is a 4 sp3 hybrid orbital, where 2 of them have a non-bonding electron pairs, and 2 of them have one single electron pairs, which is finding for the opposite spin partner. Means it's able to going to doing the covalent bond with the 1s1 orbitals of this hydrogen atom, like in a way. So this is the non-bonding pairs which is present in here, and this is the bonding electron pairs. Now look at the structural geometry in here. This is not the perfect tetrahedral structure. Here the two hydrogen atoms are at a slightly in different angle, and the two non-bonding electrons are different angle, which makes it not the perfect tetrahedral structure, and the bonding angle is about 104.5 degree. As because why not is a perfect tetrahedral structure? Because of the non-bonding electron pairs. This non-bonding electron, due to this non-bonding electron pairs, the structure is not the perfect tetrahedral structure. Right. Now come to the another point. Here what happened as per the electronegativity. So what do you mean by the electronegativity? So electronegativity is the number that gives the relative attraction an atom has for binding electron, has for bonding electron. So what is the electronegativity? I am saying that as per the Pauling scale, the electronegativity of this oxygen is about 3.5, and the electronegativity of the hydrogen is about 2.1. So the oxygen's electronegativity is greater than the hydrogen electronegativity. So what happen in the case, the oxygens are able to hog the electrons of this hydrogen's electron towards itself, and there is electron cloud are being made in surrounding the electron orbitals of this oxygen atom. Right. So what is the electronegativity? I am telling you, electronegativity is the number that gives the relative attractions an atom has for the bonding electron. Right. So as because the oxygen's is electronegativity is 3.5, if electronegativity is 3.5 and the hydrogens have an electronegativity is 2.1, here also 2.1. So oxygens are going to be hog the electron towards its own orbital from this hydrogen atom. So that makes the oxygens is partially negative charge, and here the hydrogens is partially positive charge. Right. And one of the most important thing is that this negative charge have a same magnitude like that of the summations of these two positive charge, because it able to hog the electron from this two poles of this hydrogen's electron towards itself and produce the electron cloud surrounding the electron orbitals of this oxygen atom. Right. So due to this cause, the oxygens are able to form the hydrogen bond, with the hydrogen atoms of this another water molecules. So this is the oxygen, this is hydrogen, this is hydrogen, this is hydrogens of another water molecule, this is oxygen, and this is hydrogen. So this is the hydrogen bond, and the distance between the hydrogen bonds is about 0.177 nanometer, and the distance between this covalent bond which is happen between this sp3 or overlapping between the sp3 orbitals of this oxygens and the 1s1 orbitals of this hydrogen atoms is about 0.0965 nanometer. And the bonding energy also be different. The bonding energy which is required for hydrolysis the hydrogen bond is about 23 kJ per mole, and the bonding energy which is required for hydrolysis the covalent bond is about 470 kJ per mole. So this is totally different, means the covalent bond is strongest bond than that of the hydrogen atom, because the covalent bonds happen between this electron sharing, but the hydrogen bonds happen between the partially negative charge and the partially positive charge atom, which is the electrostatic force of attraction by the electrostatic force of attraction. Okay, so at that normal temperature the hydrogen bonds are being break down at the normal temperature, and it will be also be formed, and the stability of the hydrogen bond stability of H bond at 25 degree centigrade temperature and is equal to 2 to 20 picosecond. So 1 picosecond equal to 10 to the power minus 12 second. So how is this possible, that at that particular normal temperature, when hydrogen bond between these two water molecule into the liquid state are going to be break down and it will be formed? So how is this possible? Who provide the energy? Remember one thing, that if you are going to be hydrolysis some bond, suppose you break down this bond, it's required it's release some amount of energy. When you are going to produce some bond, it's require this equal amount of energy to form the bond. So how these bonds are going to be break down? Due to the breakdowns of these bonds, it requires this amount of energy, this amount of this 23rd kJ per moles of energy. Who provide this bond? Because at the temperature and the partial pressure, at the temperature of 25 degree centigrade and the partial pressure, the molecules and atoms have an enough kinetic energy or enough kinetic energy and motion that causes the increase of this entropy. Delta G are going to be increased if the delta S are going to be increased. If delta S are going to be increased, definitely when the delta S, T delta S are going to are just have an higher magnitude than that of delta H, definitely delta G are negative. Definitely delta G is negative, because we knew that the delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. So when the T delta S is high and the positive value, when it have an higher magnitude than that of this delta H, then definitely delta G is negative, and when the delta G is equal to this 23rd kJ per moles of energy, definitely in this time the bonds are break down and the new bonds are being made. But the question is that how? Who provide this energy? When you are going to break down this bond, what happen? The microstate are going to be increased. So as per entropic law, when you increase the microstate, increase the entropy. When you increase the entropy and the T delta, same process, when the T delta S are greater than the TH, at that time when the delta G have a negative in charge, and when the delta G is negative and have an enough magnitude, the same magnitude like 23rd kJ per moles of energy, then the bonds are formed. Means at the room temperature, simultaneously the hydrogen bonds are being formed and hydrogen bonds are being hydrolyzed. And the stability of these hydrogen bonds in between these water molecules is about 2 to 20 picosecond. Means only the in between these 2 to 20 picoseconds, in between this range, hydrogen bonds are formed, hydrogen bonds are being produced at that room temperature. Means that the room temperature, the solutions have an enough kinetic energy which is provided by the transitional motions or the rotational motions of an atom, which have a same magnitude, which is required to hydrolyze the hydrogen bond between these two water molecules. Now the question is that this is the perfect tetrahedral structure, as because I already told you that the oxygen atom have and the outer orbitals of these oxygen atoms have a tetrahedral structure. Now we are going to write it down in here, tetrahedral structure. So this is the tetrahedral structure in hydrogen in here, these two poles having two hydrogen, and here this is the non-bonding electron pairs. Here seen here, this is the delta minus, this is delta minus, this is delta plus, and this is delta plus. Now here due to the outer electron orbitals of this oxygens are perfectly tetrahedron structure, that gives the property of this oxygen which is present in the water molecule do the hydrogen bonds with the four neighboring water molecule. It is possible when it will be in the ice crystal structure. So into the ice crystal structure, what happened, the oxygen's molecule which is present in here, which is perfectly fixed at the particular portions, and the motions, rotational motions or the disorderedness is not possible, and the hydrogen bonds is highly organized, highly ordered. So there is entropy which is pretty much less in negative in charge, pretty much less and negative in nature. Means they are highly organized. Hydrogen bonds are highly organized, and because due to the structural stability of this water molecule, it will be fit at the particular portion. Okay, and due to this particular portion, it will be fixed so that it doing the hydrogen bonds with the four neighboring water molecules. Okay, and whenever you are going to melt down this ice crystal to convert into the liquid form, this is called the flickering clusters of these water molecules into the bulk phase. What happened? The entropy are being increased, delta S are going to be increased. If the delta S are going to be increased, definitely the delta G are in negative charge. When it will be negative, when the T delta S are greater than delta H. So why the delta S are going to be increased? As because that the highly organized hydrogen bonds are not organized too much in here, due to the random motions of these atoms of the molecule, or molecule that have an enough kinetic energy to break down the hydrogen bonds, and it unable to forms the hydrogen bonds with the four neighboring water molecules. It able to form the hydrogen bonds with the 3.4 molecules of water molecules. Means it able to do the hydrogen bonds with three another respective water molecules, like 1, like 2 and 3 into the waters, when the water molecules are into the liquid state, and when the water molecule into the solid state, it able to form the hydrogen bonds with the four neighboring water molecule, 1, 2, 3 and 4. The hydrogen bonds always be happen in between the partially positive and the negative charge. This is the electrostatic force of by the electrostatic force of interaction. Hydrogen bonds are 10% covalent bond due to the overlapping bonding orbital, and 90% are electrostatic bond. Right, hydrogen bond are 10% are covalent bond due to the overlap into the bonding orbital, and the 90% are electrostatic bond. Just you are going to remember these things. Okay, so when you are going to melt down the ice, what happened? Entropy are being increased, and the highly organized hydrogen bonds are disorganized, so that entropy are increased and delta G is negative. Means spontaneously it's happened. And when you are going to evaporate these water molecules into the gaseous stage, the hydrogen bond which is already in disorganized form, which is highly disorganized into gaseous stage, mean delta S is high, pretty much high, and it is greater than the delta S which is into the liquid state. Means into the gaseous state, the entropy are very very high, rather than when this water molecule are being stay into the liquid phase. Right, I'm giving you some example that at the room temperature of 25 degree centigrade and the partial pressure 25 degree centigrade, and the partial pressure of 101.3 kilopascal partial pressure 25 degree centigrade, the delta H, the enthalpy required to break down the hydrogen bond, delta H is about 5.9 kJ per mole, 5.9 kJ per mole. It's required, this is the delta H, and the temperature 25 degree centigrade, when the H2 which is present into the solid state, which is converted into the liquid state. Okay, now this liquid state are going to convert into the gaseous state, the enthalpy are required about 44 kJ per moles. Means at normal temperature 25 degrees centigrade, the water molecule are spontaneously, which is present into the solid state, the spontaneously are converted into the liquid state, and the liquid state are spontaneously evaporated into the gaseous state. But the enthalpy are different because it's consume the energy, so that the hydrogen bonds are going to be break down and it going to be evaporate. So at that temperature it is spontaneous. But how these reactions are spontaneously happen? This is happen. So I already told you that the delta G, standard free energy changes, is about the delta is enthalpy minus T delta S at the temperature, absolute temperature and the entropic changes. So when the delta H is when the H2 which is present in the solid state are going to convert it into the liquid state, it's required the delta H is 5.9, is required the enthalpy is 5.9 kJ per mole. It is spontaneous, this reaction is spontaneous when delta G is negative. So when the delta G is negative, if the T delta S are greater than the delta H, T delta S have an enough value, that have an enough value, means the positive, large positive value, and greater than that the delta H means 5.9 kJ per moles. In this time the delta G is negative and the reactions occur spontaneously into the right direction. It occurs spontaneously in this direction. It spontaneously happen at the room temperature. The same process happen into the in this case also. When the H2 molecule present in the liquid state, the delta H is about 44 kJ per mole. Is a positive as because it required it absorbed the energy from the surrounding, so that is the positive in charge. Another one of the most important thing is that the same thing happen if it is in spontaneous reactions happen into the forward direction. Delta G is negative. When the delta G is negative, when the T delta S is greater than this value, okay, in this time the reactions happen spontaneously into the forward direction. And another things I'll discuss here with you, that hydrogen bonds are being formed between the partially negative charge and the partially positive charge molecule with the electrostatic force of interaction, negative and positive charge molecule. This bonds is pretty much strong. This is the pretty much strong bond when the three atoms which is involved into the hydrogen bond, are in one single line. Suppose the hydrogen bonds are being occurred between this C-O group and OH group. This is H and this is O. Okay, there is a hydrogen bond between this. Now what I'm saying, that the hydrogen bonds is pretty much strong when these three atom, because these electrons are being hogged by these oxygens, and these electrons are being hogged by this oxygen. This is the partially negative charge and this is partially positive charge, and in between this partially negative and positive charge the hydrogen bond are being made, and hydrogen bond are pretty much strong when these three atom which is involved into the hydrogen bondings are into the linear form. If it is slightly bent, definitely the hydrogen bonds is pretty much weak. In this condition, this hydrogen bond is very much weak bond, so which is found into the protein structure. So protein have a weak hydrogen bond, but one of the most important thing is that this weak interaction actually gives the property of the protein molecule to configure in any form, so that it going to be bind with the substrate molecule in its enzymatic form, substrate molecule so tightly, and convert into the substrate into the product, and they increase the rate of this reaction. Hope this video helpful to you people. Thank you.